Hello students. Now in last 2-3 lectures we have seen that how to find complementary function. So to find complementary function only we required skill for factorization, and that formulae for roots real and distinct when real roots are repeated, and formula for complex roots and when complex roots are repeated. So for that you must do practice. Now in this lecture we see for particular integral what is mean by 1 upon fd or what is mean by 1 upon d. So now our linear differential equation with constant coefficients is nothing but f dy is equal to capital X, where this f d is nothing but d raised to n y by dx raised to n plus p1 d n minus 1 y by dx raised to n minus 1 plus dash dash last pn. So for that we have used, for d by dx we used operator capital D, and our equation becomes f dy is equal to capital X. Now from this equation you can see this y is equal to, we can write it as 1 upon f d into capital X. So for this now we must know what is meant by 1 upon f d, because d is an operator or f d is also an operator. So 1 upon f d means what? So definition of this symbolic function 1 upon f d is 1 upon f d operates on capital X is defined as that function of x which when operated upon by f d gives capital X. Means this 1 upon f d operates on capital X. This is a function that when f d is operated on this function 1 upon f d capital X, this gives capital X. So you can understand this is similar when we always use in our arithmetic that x into 1 upon x gives 1. So like that f d into 1 upon f d get cancelled and remains only x, but this is not like that. So 1 upon f d has some meaning, and this 1 upon f d is nothing but it is inverse operator of operator f d. That means f d is equal to, f d is function polynomial of capital D. Capital D is nothing but d by dx. So 1 upon f d is inverse operator of f d. For example, suppose f d is only d and d is d by dx. If d is d by dx, then that means when we operate d on capital X, that means we have to take derivative of capital X with respect to x, because capital D is nothing but d by dx. So capital D into capital X or capital D operates on capital X, this means that derivative of capital X. Therefore, 1 upon D is inverse operator of this capital D, means 1 upon D operates on capital X gives integral of X, because integral is inverse operation of derivative. Derivative and integral, these are two inverse operations. Therefore, if D operates on a capital X, if it gives derivative, then when 1 upon D operates on capital X, it will give integral of this capital X. Therefore, 1 upon D into capital X is equal to integral of capital X dx. So, this is very important. See here, for example, one upon D into, suppose capital X is equal to x cube, then 1 upon D x cube, this means integral of x cube with respect to x. So this is nothing but integral of x cube is x raised to 4 divided by 4. So this is how we operate 1 upon D on capital X. So now we see other factors like 1 upon D, because FD contains factors also. So then to find particular integral, we must find value of 1 upon FD into capital X. Therefore, we must know how to evaluate one upon any factor like D minus A, where this A is constant. So many times we have to do this to find particular integral. So to find value of this 1 upon D minus A into capital X, consider this nothing but value of y is equal to D minus A into 1 upon D minus A into capital X. So we have to find out value of y. So we solve this, multiplying this by D minus A, we get D minus A into y is equal to capital X. Now we operate this factor D minus A, then we get D of y minus A of y is equal to capital X. D of y means d by dx of y, that means this is nothing but dy by dx minus a into y is equal to capital X. Now to solve this equation, we must know that this is nothing but linear differential equation. So this is linear differential equation. So the standard form of the linear differential equation was dy by dx plus capital P into y is equal to q. So this is a standard form, and to solve this equation we must know integrating factor is equal to e raised to integral p dx. And solution of in linear differential equation is y into integrating factor is equal to integration of integrating factor into q dx plus constant of c. Here we don't take constant of integration. So now in our equation, what is p? Here p is equal to minus a, coefficient of y is p, and q is equal to capital X. So we must find integrating factor. It is equal to e raised to integral p dx, means minus a dx. That means integrating factor is equal to e raised to, this minus a is constant, integral dx is x. So e raised to minus x is integrating factor. Therefore our solution is solution of equation 1. It is y is equal to y into integrating factor. Integrating factor is e raised to minus ax. This is equal to integration integrating factor e raised to minus ax into q is capital X into dx. So this is our solution. Here to find value of y, we have to multiply this equation by e raised to plus ax. So by multiplying e raised to plus ax, we get, so here y into e raised to minus ax into e raised to plus ax is equal to, here also we multiply e raised to ax, so e raised to ax outside the integral, and then multiplication with this integral e raised to minus ax into capital X into dx. So here e raised to minus x and e raised to plus x get cancelled, that means e raised to 0, which is equal to 1, and we get only y. Therefore we get y is equal to, this is e raised to ax into integral e raised to minus ax into capital X into dx. So this is nothing but our formula for this y is nothing but, what is y? We have substituted y for 1 upon d minus a into capital X. So value of this is, we have got here, that is e raised to ax into integral e raised to minus ax into capital X dx. So you must remember this formula, because to find particular integral many times we have to find this, we have to use this formula many times. Now similar to this, we can calculate or we can derive the another formula, that is 1 upon, only instead of minus there is plus a. This operates on capital X. This is nothing but e raised to minus ax into integral e raised to ax into capital X dx. So similar to above formula, you can derive this formula also. So we can find using this formula. Suppose we have to find that is 1 upon d minus 3 into cos x. If we have to find value of this, then now here a is equal to 3. Our formula is 1 upon d minus a operates on capital X is equal to e raised to ax integral e raised to minus ax into so using this formula we can find this value 1 upon d minus 3 into cos x. This is equal to e raised to a means 3, e raised to 3x into integral e raised to minus 3x into capital X is cos x into dx. So after solving this integral we can find value of this. So in next lecture we see some examples to use this formula. So we stop here.